Cool? Okay. We'll try and breeze through. Because what I would love to get out of today is just talk to all of you, really. I'd love to hear your feedback on this stuff on a one-on-one basis, but I'd also love to hear what I can do to help. Okay. So, compute over data. I'm going to talk a little bit about a project that we've been working on at Protocol Labs to help get this started, but really what I want to get out of today is let you know about the work that we are doing around compute over data. You heard Charles talk about compute over data. You're going to hear this theme many, many times. This is not a Protocol Labs, IPFS, Filecoin only thing. This truly is something where we want to collaborate with everyone because, as we've said many times so far, there's so much data on IPFS already. So much. Adding an enormous amount every single day. And it's up to us to help people use it. And we as a community collaborate and say like, well, we think this is the way things should go. I'm going to go off and take this one, and you're going to go off and take this one, and let's figure out how we can work together and solve real people's problems. Okay, so I mentioned the data today, storage deals and so on. The amount of data, things coming online on IPFS and Filecoin is enormous. Over a petabyte a day, and that number just keeps going up and up. And big data, by and large, we feel like will affect every industry. It already really is affecting every industry today. You can see here a recent report about it. And you can see some, impossibly big data numbers. Data quality hurting people's organizations, the amount that users generate per day, and so on. Netflix saving over $1 billion on user retention. And Google, attacking Fusion, all through big data, right, with impossibly large data sets. Unfortunately, what you see a lot of the time is stuff like this, where the success rate for people using big data is actually quite low. And in particular, as the data gets bigger, it becomes even lower. And a lot of times it's because the tooling hasn't caught up. It's very easy. This is like, 1980s technology to be able to take bits and write them to a magnetic platter, or now, flash storage or whatever it might be. But, that's nothing new, and the POSIX file system and interfaces are, since were invented in, 1970. Using that data is actually really challenging. So, one thing when we started to think about compute over data and making this accessible is really start to think of how data developers work. So when you think about data developers, there are a lot of them, 4 million of them today. They're growing extremely quickly, and they're oftentimes asked to do things across the spectrum, from transforming data, using it, analyzing it, actually producing models or results from it, and selling it up the chain. And more often than not, they're really ignored by standard development tools, which is a bummer. And they're asked to use Terraform, to use Jupyter, to use Python, to use R, MATLAB, all the way up to Kubernetes and actual deployment technologies. When you ask them where they face most of their challenges, it's stuff like this, right? You can see the majority of it is just in that early section. You would think the majority of the time is spent building the model on this big data or building the analysis on the big data, but it's just at the beginning. Loading, cleaning, and visualization. And the extent to which we can focus on this and make it easier for them, I think, is incredibly powerful. So what's the typical data pipeline for those that don't know? It oftentimes will look like this. You ingest it, you process it, then you do some engineering on it. Like I said, change dates, change formats, whatever. You split it into your test and training data. You train it, and then you serve the model to your application. If you're doing your job right, it ultimately loops back. But in truth, our focus is really here at the beginning, right? Where let's try and attack this problem at the start so they can focus on the much harder problems at the end. So what would they like? Well, our thesis is that data developers would like something like this, right? They want it to be familiar. They want it to be simplified versus what they use today. And most of all, they want it to be collaborative. So what does familiar look like? Well, when people think about how to use data, a lot of times they think about what you see here, right? I'm just going to go and build a model. But the truth is, it's not just about building a model, right? It's about all of these steps in a complex data pipeline. And if you just focus on the first steps, and in particular, a narrowly defined set of tools, you're going to make your data developers unhappy. This is a study came out of Microsoft that said, one of the most sophisticated data organizations in the world with over 159 different tools that they use. And again, these are people who have so many tools at their disposal. They're just using whatever is familiar to them, and they want to pick and choose the things that make sense. So if you ask them to choose just one out of these to solve all your problems, round peg, square hole. And we haven't even gotten to the platforms yet. That's just the tooling. The platforms, you have all these various compute providers, and then you have all these various data platforms. And I'm not even scratching the surface here. The truth is this is too many choices, oftentimes. Now, it's not too many choices for your organization. That might be great. But to surface these for people who just want to use this very large amount of data is not a good thing. So I joke about 1970 earlier when I talked about POSIX. It's not even wrong, right? SED, one of the most popular tools out there in the world, is 48 years old. I think we should bring data science back to the 70s. So that's familiar. Give people the tools they already know and love in a new, updated, scalable way. Second is making it simplified. So if you use those tools but you make it incredibly complicated, that's not good either. This is a very standard kind of like out-of-the-box model that people use. It's the housing prices example. It's like the hello world of doing things in data. If you do this in a Jupyter Notebook or in raw Python, it's around 5 lines of code, and even that is a little bit much, right? If you want to do the same thing in Hadoop, it's this. And this doesn't even capture everything, right? It's an enormous amount of stuff. You have to port from Python to Java. You have to understand distributed compute. You have to do all of these various complex things, which is super annoying. And then that's just the developers. If you want to do it, if you want to get it out there, you have SREs, the site reliability engineers, the people who keep your infrastructure up and running, feeling the pain too. So for example, you have your data scientist here who comes along and says, I found a data set. Can I engineer it? The IT ops person says, well, I have to go provision your cluster for you. Takes some time. And then finally she gets around to provisioning it, and she says, okay, you can do it, but now the first thing you need to do is all this, right? And again, remember that housing example, how easy it was, 5 lines of code? They have to do all this to transform it just to take advantage of the infrastructure that's now been provisioned. Once that's done, they can go and roll it out to these, and hopefully they finish it properly. Of course, then they leave it up and running, and they forgot to turn it off, blowing their entire budget for the year, which again is not at all surprising. This happens all the time. So the one thing that data developers and SRE can agree on is that MapReduce sucks. It didn't suck. It sucks now. So we can do better. And a way that we can do better is really leaning into collaboration, right? So for collaboration, if you go to look at any of the large compute providers today, they will have very often very large data sets that are out there already that work very well. Unfortunately, they're very isolating, right? They're the raw data from these major organizations. Nobody knows what's going on. Nobody knows how to format them. Many people just have to repeat these same tasks over and over again because there's no simplified way to share them. So for example, let's say you have your 3 different data scientists here. One wants to take these Landsat images and tile them, super common, to tile them into smaller images so that you can run them. Some may want to scale it, so reduce the amount of pixels so it's easier to push around and make your models. Some may want to grayscale it. Again, based on your model, this is what you want. Now you have a 4th data scientist who comes along and says, well, I want all 3 of those. And again, that's super common. Maybe it's someone else in your lab. Maybe it's someone in a corporation across the world. And she would now have to repeat each one of those steps in order to replicate the work that has already been done by these people. You could imagine a world where instead, when each person finishes those data sets, they publish the results into a universal location, for example, IPFS, and then this data scientist could instead derive her data set from those original data sets, and which then is further published, again, optionally, if she wants. So that's what I mean by simplified, or familiar, simplified, and collaborative. And I think that we can get there with small changes for data developers. And that's where we get to compute over data in Filecoin. And again, I'm going to give you an example of one, but this is something where we want to build an entire ecosystem around it. Our initial offering is called Bacalhau. Bacalhau means COD in Portuguese, COD, compute over data. See, it's a pun. And our goal is to transform the way that people have access and use big data by giving them first-class tools that enable truly distributed working and unlock this collaborative ecosystem. The way it looks right now is what you see here. Again, and I'll show you a demo in just a second. Here you can see you add your data to IPFS. You then submit your job against that cluster, and then you fetch the results, and presto, you're done. No special clusters, no temporary, no transfers. The results are automatically added back to the chain. It's familiar commands, I know sed, and it works just fine. Automatically resolves failures, and incredibly cheap. And cheap not just in money, but also in time, because you don't have to move these petabytes of data down from where it's being stored to run this trivial compute on. And we're just getting started. And like I said, I mentioned no egress. So these scenarios, I found a data set that's perfect. She runs her job, off it goes, and then it's done. And our SRE learns about cat videos on YouTube. All right, so how real is this? Well, it's very real. Let's pop over here. So this is a video recorded very recently. I think it was actually recorded today. It may have been yesterday. There we go. So you can see here, our cluster is out there. It's live. You can go right now to bacalhau.org. You can go get it. We're up to build 0.17 and mess around. There's instructions and, of course, an active repo and Slack channel, and we'll get there. Here, I mentioned the Landsat videos. I've downloaded them to a directory, which I'm going to want to parse over in just a minute. I take those those Landsat images and I upload them to IPFS. And now I'm going to execute a very simple command. Now, this is a little bit more complicated than you're going to see shortly. We're doing a lot of work on the API to simplify it. But you can see there, if you're familiar at all with Docker, it's going to feel very, very similar. I just use the image magic Docker, and I give it a command. I say I want to downscale each of these images to 100 by 100, reduce their quality to 100, and then republish the things back up to IPFS. You can see there, I took it and I ran it. And from there, you can actually watch this command running. So we'll sit there and let it chug along. Momentarily, it will finish, which it did. And you can see there it posts the results. And, it paused, sorry. Post the results back. And now I'm going to go get those results and download them. Here I just grab that job and I download it. And I pop over to this directory of all these images, and you can see now it's done. Okay? I didn't have to download it. I didn't have to install anything. I didn't have to know image magic beyond the basics. So that's it, just getting started. Like I said, you can reuse Docker containers. One thing that we're extremely excited about, and we're happy to announce today, is we also support WASM. So WASM enables you to do truly deterministic jobs. So instead of using Docker as the runtime, you'll be able to use Python compiled into WASM in order to achieve that. And here you can see this is a hello world. Here we're able to execute this deterministically. In this case, we're just going to say hello Toronto just to make it fun. Here I ran that job, and it's going to output to a simple file that hello Toronto. And when I go and I get that job, I download a text file, and I open it. And here's my text file, and as you can see, presto. Hello, Toronto, right? All executed deterministically. Now, I didn't have to understand, again, didn't have to understand WASM, JavaScript, anything. We took care of all the compilation. We ran it for you on the back end and so on. And our goal here is to make all of these things transparent. We've already tested out privately. I will not, absolutely no guarantees, but we've tested out privately many popular data libraries, including NumPy and Pandas, which do compile down to WASM. So we're really excited, and we'll be able to offer deterministic execution shortly. Again, hopefully come watch us in the Slack channel. We try and be very, very public about this. Okay. And speaking of Slack channel, there it is. See, I'm not lying. I have it open all the day, all the time. Okay, so wait a second, you might ask, what about all these things? Homomorphic encryption, federated learning, security, hardware, enclaves, blah, 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 blah. We promise we will get there, just not yet. We're trying to make this very usable and very scalable today, and then offer additional features coming shortly. How scalable? Well, we've, just as of last week, finished our performance results for our initial kind of hello world example, and we were able to do 10,000 job scheduling. It took about 653 milliseconds to resolve each job, and we saw no failures, right? So obviously we're not pushing it hard enough because no failures is impossible, but it is true that our hello world had no failures and 5.9 plus job resolution. So optimistic. We will continue to ramp up and push until we fix this, until we are understanding the bounds of this, but we're really excited. Our goal is to be production ready with this by October, which we consider production ready to be when you're running 1,000 nodes, 10,000 jobs, petabyte scale processing over this. Landsat, for example, that I mentioned earlier, it's a 1.8 petabyte data set. We want to be able to handle Landsat. Actually, we want to be able to handle bigger than that. The human genome is even better. 99% job success rate, 49% malicious code nodes using deterministic execution, and we have a good strategy around that, as well as DAGs. So you no longer have to spin up a complex DAG or anything like that. A DAG, a distributed acyclic graph, where you take one thing and you push it all the way through. We want to be able to execute the whole thing on there, right? And again, we're just getting started, and I cannot stress enough, it can't just be us. We promise. If it's just us, I will have failed. We will have failed as a community. We want this to be something that everyone can focus on, right? So here you can imagine that different teams can gather around these different areas and work together and say, hey, you know what? I know how to do distributed machine learning. I know how to do job serving. I know how to do what 6 different people know how to do execution against hardware enclaves. Who knows, right? And it's up to us to figure out how we build the right interfaces between these components and enable everyone to build great businesses on top of this. It will not just be us. But I want it now, I know. And that's on you. We need you, we need your feedback, we need your use cases, we need your real world pain so that we can go out and do it. Here are 4 examples of things that are running right now, either running or in the process of being a part of our core use cases to run. You can see some of the examples here: cell modeling, a surface CO2 analysis, things like that, where the data is residing on Filecoin and we are running computation against it. So that's no downloads. And again, just to give you a small example, again, I mentioned that Landsat earlier. Landsat 1.8 petabytes. To just download that at half a gigabyte GPS, bytes per second, would take a day and a half, right? You're doing it now with 0 download, right? 0, executing where it is. Key collaboration opportunities, like I said, developers. If you know WASM, if you know MapReduce, you know orchestration, love to talk to you, love to help learn from your experience. Use cases, we have tons of content on IPFS and Filecoin. We'd love to hear about it. Scientists, users, people who have too much data and not enough compute, we're here for you. But most of all, partners. We want to accelerate your businesses. We want to take the boring stuff and build it into the base of the platform, either in Filecoin proper or Bacalhau or something else, and figure out how to go from there. And like I said, if you're building a platform or tooling to accelerate data scientists, data developers, democratize data generally, we would just love to talk. New Computer Over Data Working Group. We are, again, I cannot stress enough, I am just one individual in the group. But by and large, we would love to begin this process of collaborating together in a more formal way. So once a week, we are going to get together and chat. People are going to demo. People are going to talk about things that they're working on, whatever. Normally I say don't go and scan a QR code because that's super security, but you can trust me on this one. We also have a bit.ly link there if you want to type it in, incognito or on your hardened machine. But there you go. So here's the picture slide for you to grab everything. We have our web channel, we have our email list, we have our Slack, we have our repo, and again, I cannot stress enough, we want to help you. That's me. Come call me, email me, DM me at any hour of the day. I'm happy to help. With that, I don't know how timing is going since we had all the problems at the beginning, but like, I'm happy to take, I don't know, 5 minutes of questions? Or no minutes of questions if no one answers you. Yeah? So the jobs are actually, so again, we're early. Right now, the nodes, the test nodes that we have going, will pull the data down to them. So you will face the egress time there. In the future, in the dream world, storage providers who store this data will be able to run Bacalhau on top of it. And, again, I will stress, we haven't really figured out incentivization. We would love to talk to folks about it to encourage people to run these nodes. But the ideal case is every single node that has a storage on it, Lotus or any Filecoin storage on it, will also have a compute provider on it as well, and you will selectively say, I want to use that data, and then that person will bid on the job. Other questions? Okay. Oh, yeah, go ahead. Well, it turns out that storage provider nodes are quite beefy. So they're are quite beefy. They mostly have GPUs. They mostly have enormous RAM and so on because they're out there, providing storage, which is a very intensive thing for those that don't know. The compute for it is intensive. It's not often that they have this intensive thing, but when they're asked to provide a proof, that's just cryptography. So you got to do a lot of work on that. Exactly. Yes. Exactly. Exactly. Yep. So figuring out exactly what this runs as, like nice level, whatever, 10,000 is, kind of we're still figuring all that out. So far, we're able to thread it and operate on it quite powerfully. As you saw there, we were able to do 10,000 jobs, and each node didn't get overwhelmed. Like they're basically able to pick up the job as it comes along. That said, there's going to be a lot of tweaking on this, and we're going to start as low as humanly possible. Like our dream is to be similar to SETI at home and just run as screensaver. Again, not literally run as screensaver, but you get the idea, yeah. Anything else? Or, by the way, like a storage provider could say, hey, I actually super care about this, and I'm going to build a machine perfectly designed to run Bacalhau. I want it to run at, nice -1. Make sense? Questions? Well, I'm here for the next 3 days. Love to do the hackathon, love to do whatever, show you how it works. I'll also be for those that are going to Iceland, I'll be going there as well. Cool. All right. Thanks, everyone.